Good afternoon, my name is Dr. Maxwell Marlier-Parfit. I'm from Coins Fulcro, and I'm going to be talking to you today about visualization for the AEC sector, the past, the present, and where I personally think it's going in the future, and then we'll look at how it can help you this day and age. So to give you a quick intro, I'm part of the Fulcro group. The Fulcro group being a collection of companies, Fulcro Engineering Services, Metz Architects, who Emma at the back is representing, and then Coins Fulcro, which is a strategic partnership between Coins Global, large software ERP, back of office financial company, handling very large data sets, and Fulcro, coalface, MEP, virtual design construction company. And Coins and Fulcro have come together to really build a unique partnership to actually help drive forward applied technologies for the construction sector. So, quick overview of my presentation today. We're going to be having a look at the importance of data, so the good, the bad and the ugly. We'll also be having a look at what exactly is visualization and how it's being used in construction. We'll have a look at then virtual reality and augmented reality technologies. And then I'll also be introducing the FullMax system, which is a brand new product launch, and I'll give you more details about that, but please do come see us after the show or after my presentation up on stand M21. So, the importance of data. Everyone here, you have some dealing with data in your day-to-day lives. We've had ugly data in the past, silos of data that just don't talk to each other, inoperable data standards, very difficult to get things to and from each other, and quite often paper-based deliverables. So we've all seen the big racks of A1 sheets trying to give 2D drawings explaining a three-dimensional object. We've then got bad data, in my opinion, which is the present. We've got legacy data sets which we have difficulty getting into a modern standard. We have too much generated data that is then not used. Quite often the client just ends up putting the data on a DVD in a bottom drawer and let it gather dust. And too much data. A lot of people are finding that there is just far too much information out there at the moment for them to be able to process and handle effectively. So where are we going in the future? Well, my view of good data, we're going to have whole supply chain engagement, so linking in with the ethos of BIM Level 2 and having all that data pushed back up, so you know that when you're taking an object from a library, that data is being certified by the product manufacturer, you know the data is correct, you know the life cycle of that information, and you're confident and you can put it into your product without having any issues. We'll also have interoperable data standards. So IFC hasn't really lived up to expectations. We seem to use IFC and then lose a lot of data if we do ever touch it. So we'll have properly interoperable standards where we have no data loss and everyone is talking common language. So these are the dreams, but we're getting there, and we're just pushing it forwards. So what exactly is visualization? Well, it's any technique of creating graphical or visual imagery that you can use to communicate your message or your information. Visualization through visual imagery, well, we've got there 2D drawing board. It's been an effective way to communicate since the dawn of man. So a couple of examples. We've got cave paintings depicting scenes of battles with animals and other tribes. We've got ancient Egyptian hieroglyphics. We've got Leonardo da Vinci's Vitruvian Man being able to depict the human body in new ways. But coming into a bit more of a modern times, we've got the wonderful Excel bar charts. We've got the Gantt charts showing our schedules and being able to move data along through a 4D time sequence. And hands up, who's seen the wedge in the corner? Yep, a couple of you. So that's the Mervyn. There we go. So moving away from that one as quickly as possible. So visualization in construction. We've got up the top virtual reality. So we've got the capability of doing neighborhood level planning. We can then go down onto street level to actually see how that neighborhood might look from the sidewalk. On the top right hand corner there, we've then got immersive virtual reality, and we'll cover that a bit more later on, where you can actually stand inside your BIM model. Down the bottom, we've got augmented reality. Again, we'll talk about this more later on in the presentation, but it's all about taking known landmarks within a virtual world and overlaying data onto the real world so that you can actually make decisions and have a bit more of an informed discussion about things. So, starting off, VR can show end users or clients what their building might look like to within a certain degree of margin. And it also lets users explore freely so they can navigate through the environment. And as you're seeing, and we've got a lot of it, we've got the Soluus Dome behind us, we've got Oculus Rifts around the room, we've got a lot of VR in construction. There's still a hurdle to overcome because there's still quite a lot of difficulty getting 3D models into a virtual reality ready format. But I'll be discussing the Fullmax later on to try and ease that pain. But also with the advent of BIM Level 2, we've also got three-dimensional data. Quite often in the past, with virtual reality, you'd have to build the 3D models from the 2D plans ready for visualization. But now there's a plethora of 3D data out there that we can actually grab and use straight away. So, mentioned head-mounted displays. From the very uncomfortable on the left, moving through at the top, we've got the early Oculus development kits, right up to the latest commercial version, which you can go out and purchase now. Down the bottom, we've got the HTC Vive. I've just seen we've got two here on the stage. We've got the Samsung Galaxy Gear, which has got a huge publication and a lot of drive behind it from the industry. But then also we've got the latest Sony Morpheus, which is the Sony VR, which is with the new PlayStation 4. The problem with head-mounted displays, though, are they're single-user. Construction, it's a very collaborative industry. You don't want to have someone locked into a single visualization. They're blocked off from the world by wearing this headset, and only they can understand what they're looking at. So this moves us on to room-scale immersion, and this is where we can actually sit people at life scale or close to life scale within a virtual environment. So whether they're sat looking at an interior organization on the left, or if it's the likes of Procter & Gamble looking at how they're going to lay out their new superstores to work out the best layout for their products, right down to actually visualizing a new development that we've got down in the bottom corner. The problem with room scale immersion, however, is quite often it's quite dark, can take up a lot of room, but there are also challenges to be overcome. So, to try and overcome these challenges, I worked at the University of Reading for a number of years, developing technologies, doing a lot of research into virtual reality. I have to just thank the EPSRC for funding the research. We had Crossrail engaged with us to do data testing for our product work, as well as a couple of software providers. So, challenge. We have a multi-million-pound facility that's located in Reading. We want to bring people out to see it and visualize stuff in fully immersive 3D. But it requires people to travel out to Reading. Crossrail turned around and went, we want that, we want it in our offices. Have you got a spare £1 million? No, fine, what can you do? So what we've got here is the 3D Move, and this is a very early prototype. So all I've done, this was unloaded from a van, and all we've done is sped up the video, nothing else. So you've got a time code in the bottom corner there. So we had a false floor that we could lay out on the floor. We've got all of a frame made out of carbon fiber. It was very light. The entire solution, including projectors and computers, weighed just under 100 kilos, so you could ship it around on a single trolley. The whole thing just goes together like a tent. It pops up. This was only the second time I'd ever put it up as the designer. It was the first time that these chaps had ever seen it. So the screens go up. We've got integrated 3D printed tensioners in them. Again, this was prototyping, but these pull the screens taut. We then roughly align some projectors. They're out of shot, out the sides, and you get a rough alignment of those projectors in Windows. We then log into Windows, we run a calibration process across the three screens in this case, and from arrival to fully visualized room scale immersion, 32 minutes. And that was with a pre-compiled virtual reality model. Problem with this model, it was designed for an iPad. It was very lightweight, there was no engineering data behind it. It had all of the interesting stuff from a construction point of view cold. It was there really to do public engagement with. So people could download the app on their iPad and explore the new station. This is Whitechapel Station, part of the new Crossrail development. And this was a visualization to start looking at what, if we change the tiling on the floor, what different types of marble we might like, where we might put in advertising posters. So it had its use. However, it was limited as far as construction goes because you could only view data. You couldn't actually interact with it in any way other than navigating round. Just to prove it is one-to-one scale. My wife hates the photo on the left because it's her, but it's one of the best photos showing scale. It's her tapping in with an Oyster card. And we've got some chaps there. You see they're wearing 3D glasses. We have the capability of doing stereoscopic. So if you go to a cinema and watch a 3D movie, you wear these glasses which give you the depth perception to give you an idea of scale. So, moving from virtual reality, we'll circle back to it in a minute, to augmented reality. And AR is the capability of taking something, whether it's a tracker, such as one of these, or just a QR code, and being able to overlay data onto the real world. So you can see the picture on the screen there. We've actually got a fully built model. This is as built from the building as it's being put up. And you can see the model again on our stand M21, so come and explore. But we can overlay GPS data, GIS, graphics, BIM, CAD data, all onto a mobile device. And the use of it in construction is currently under experimentation. A lot of construction companies have a blanket ban on mobile devices on site. But this is moving forwards. There are policies in place and safe working areas. But we'll come on to how we can get around that in a little bit. So, some just graphical examples here. We've got on the picture on the left, we've got a code on the floor, and we've got a chap here on an iPad just looking at different staircase designs and how it will fit within the existing infrastructure. So doing retrofit, I was chatting to someone earlier about doing store fit out and seeing different options and doing optioneering around different designs. The top image at the right, this is, we put a marker, a big cube on a stake in the ground at a groundbreaking ceremony, and anyone who comes to the site can download the app and actually see what the new building is going to look like before we've even stuck a spade in the ground or laid a foundation. So they can see it in situ on site to scale. Similar, and the bottom two images looking at interior design, but also you see on the bottom one we've got a business card there overlaying a 3D model on top of a business card. So again, this all takes handheld devices, but we're now starting to see devices such as the HoloLens, the DCW smart helmet, where you're actually able to wear it. It's a wearable piece of technology. It frees your hands, and you can still see the real world through it. In fact, the DCW helmet, they're currently doing testing to make it impact rated, so you can wear it as a usable piece of personal protective equipment. And what we're going to show you now is just a quick video of the DCW smart helmet in action.
Now, let's see what it looks like first person. This video doesn't use any special effects. It's shot directly from the smart helmet. As you'll see, the pane on the right is what the helmet sees, and it's synced up to the one on the left. So when the helmet looks at a piece of equipment, it's actually using computer vision to understand what it is, and in this case, it actually has a work ticket. So it's going to tell the worker for the first who may be doing this job for the first time, exactly what to do step by step. How to perform an inspection. When it finds a reading that is out of range, it's going to tell him to replace the filter. And it's going to show him every step of the way how to do it. It's all done by the helmet. We call this one the arc reactor. It's in our training center in LA. One of the most complex systems by design. And you can see how looking at it with a smart helmet, anyone the first time they do this job can do it almost as well as an expert. And that's important in today's workforce, where you're trying to cross bimodal workforces, where you have experts that have been there for a long time, and maybe you have younger workers that are hard to recruit, hard to retain. They change jobs. What if they could put on a helmet and know how to do any job, and to do it with less errors and more safely?
So less errors, more safely. If we can put this technology out onto a construction site, even if the person is new to the site, we can have, say, interactive maps to show them where to go. Safe walking zones, which may change on a day-to-day basis depending on the activity on site. And being able to also scan, because these helmets have many cameras in them, we can scan the site in real time as they're walking through, which is creating your as-built data. Rather than having to send someone out with a laser scanner once a week, all the people who are wearing these helmets will be building up a continuous map of that site. So you'll be able to say if there was a near miss or an incident, you'll be able to see the exact state of that site when it happens, whilst still being able to pass that information back. You're also able to do things like remote assist. So if you've got an expert elsewhere, could be in another country, we can dial them into the helmet and they can talk the user through how to solve a problem. So As I said, I'd circle back to virtual reality. I'd like to introduce to you the Fullmax. This is a product range that we are launching today at Digital Construction Week. This is through Coins Fulcro, so the applied technology integration. And the Fullmax is a virtual reality environment which has been designed from the ground up with the construction sector in mind. So rather than pinching technology from the entertainment sector and adjusting it to work, we've spent 2 years developing this technology from the ground up with partners such as Crossrail to actually find out what do you need on a construction site, what do you need in a construction design office, and can it fit in the office? So this has been designed to sit within a 2.5 metre by 2.5 metre square footprint. It stands at 2.25 metres tall, so it will fit under your drop ceiling in a standard office, which includes space for fire sensors and lights, so it's fully rated. And this system projects onto the 3 walls and the roof, is seamlessly stitched and allows users to then stand inside the model at life scale. The positive of this is you can have very engaging collaborative discussions around your technology, but also around the building design that you've got there in front of you. But further than that, the Fullmax system sits on top of the Fullmax Keystone software, and some of the pain at the moment with virtual reality is taking a 3D model, processing it, converting the materials, exporting it again, bringing it into a games engine, programming some interaction, and then exporting to a device. What we are working on, and we'd love to hear from anyone who's interested in beta testing the software, because we're due for release next year on the software, is we are making it a one-click process. If you're in Revit, if you're in Bentley, if you're in Tekla or Solibri, up on the toolbar will be a button. You click that button, you go away, make yourself a cup of tea, and by the time you've walked back to the Fullmax, it's done all the model processing in the background, and a fully ready to use virtual reality immersive experience is there waiting for you. It means the data never leaves your business. No longer are you having to send this out to an external rendering company, so your data is secure. But it's also no longer you waiting for someone to process that data for you. Because the processing is all being done in-house, your data is ready at the click of a button, and your engineers are ready to go with that data in their hands. So it's been a very quick whistle-stop tour about virtual reality and augmented reality, the past, present, and future of visualization. I'd love for you to come see us on Stand M21. I've got some augmented reality coasters. You can, if you've got an iPhone or an Android working on Windows Phone at the moment, you just go on your App Store, download the Fullmax app, full details on the coaster, and you'll be able to experience augmented reality yourself on your own personal device. So please do come see me afterwards. If you can't see me straight away, do come see us on Stand M21. That's Coins Fulcro, and come and experience virtual reality for yourself. Many thanks.